So welcome back to part two of 212. So in this case, again, we're looking at doing matching the names of the approaches. We already talked about the three different methods: rewriting, looking inside, and undoing. So rewriting is when we rewrite the equation by using the derivative property. So if we multiply things out, right, or if we simplify fractions, something like that, that is considered rewriting. Looking inside is when we are thinking more about the problem, right? Like in the previous thing, we were thinking more of like four times what gives me 20. So we know that like it was x plus 3 was equal to 5. So 4 times 5 is equal to 20. So it's thinking more about the problem, right? Just reasoning about it. And then we have finally undoing, which is we're using the inverse operations to be solving our equations. So again, all three techniques are perfectly valid when you guys are solving any type of equation, right? Sometimes you're gonna have to rewrite a lot of things. You're gonna have to be undoing things, and for you to be able to solve the equation to find a solution. So let's look. Just in this case, we just want to match the names of approaches to the left with the examples of the right. It says if 5 raised to the 8x equals 5 raised to the 24, then 8x must be equal to 24. So again, is it rewriting, looking inside, or undoing? So here I would say this one has to be looking inside because they're thinking more about the problem, right? They're thinking that if we have two things that are the same here, our two bases are equal, then our two exponents must be equal. So that's the reasoning behind uh, the the then part here. So that's the undoing. Part B says subtracting is the opposite of adding. So for the equation, 3 times x minus 7 plus 4 equals 23, I can start by subtracting 4 from both sides. So subtracting is the opposite of adding. So they're doing the inverse operation here, which would be the undoing, right? We're undoing the adding the 4, which is subtracting 4. And then finally, this problem might be easier if I turn 4 times 2x minus 3 equals 31 into 8x minus 12 equals 31. So here, in this case, they use the distributive property to multiply these two out. So this would be the rewriting technique. All right. So let's look at the next set of problems. We have work. So we want to solve each equation. For x, it says use the distributive property or draw each area model to help you rewrite the products. Be sure to record your work for each step. Check your solutions in the original equation. All right. So we have a little bit of work done already there, but we can take that off. Okay. So again, what you guys want to do first is make sure that you write your line, right? You want to separate the left from the right side of the equation. And then let's look, sorry about that. Let's look at the equation itself. Let's look at 5x squared plus 43 equals x times, we have x minus 1 times 5x plus 6. So what we want to do first is check to see if we can simplify anything on the left side. And if you notice, we cannot simplify anything on the left side, right? There's no like terms. So 5x squared plus 43 stays exactly the same. And then on the right side, I'm multiplying two things, right? I have two parentheses. So x minus 1 and then 5x plus 6. So here we have to use the box method to make it a little bit easier for us, the area model. So we're going to draw our box. We have x minus 1 and then 5x plus 6. So we multiplied things out again. X times 5x gives me 5x squared. X times 6 is 6x. 5x times negative 1 gives me negative 5x. And then negative 1 times positive 6 gives me negative 6. So that becomes the right side of our equation. Remember to combine the like terms here, 6x and minus 5x. So that leaves me with 5x squared. And then positive 6x minus 5x is positive 1x minus 6. And then from there, we want to start simplifying again. You want to move all your x's to the same side and then all your constants to the opposite side. So here, I'm going to subtract 5x squared from both sides. Let's start off with the big ones right there. So this becomes 0, and you just have 43 left on the left side. And then that equals, this again becomes 0, and you just have x minus 6. So here you can stop and think about the problem again by using the looking inside technique, right? What number minus 6 must be equal to 43? Okay, so, and then by undoing, we would just undo the negative 6, which would be adding 6 to both sides. And that leaves me with 43 plus 6 is just 49 equals x, and then you can just rewrite it again as x equals 49. Still the same thing. And then on the part B, so again, you want to draw your line. So we have x plus 3 squared equals x squared minus 3 times 1 minus x. So on the left side, for sure, we do have to use, right, the box, because that means the x plus 3 squared is x plus 3 times x plus 3. So let's draw our box right here. X plus 3, x plus 3. So x times x is just x squared. X times 3 is positive 3x. X times positive 3 is again positive 3x. And then positive 3 times positive 3 gives me plus 9. And then again, you want to combine the like terms, those two. So this leaves me with x squared plus 6x plus 9 on the left side. On the right side, x squared is by itself, so I'm going to leave it by itself still. And then I have a negative 3 times 1 minus x, so I want to distribute the negative 3. Negative 3 times positive 1 is negative 3. Negative 3 times negative x gives me positive 3x. And then from here again, let's keep simplifying. So let's get rid of let's see what happens to the x squareds. Let's move into the same side. So subtract x squared from both sides. So this becomes 0 again. All right, and then I'm left with 6x plus 9 on the right, on the left. This becomes 0 as well, and you have negative 3 plus 3x. And then again, move the x's to the same side of the equation. So I'm going to subtract 3x from both sides now. That leaves you guys with 3x plus 9 equals negative 3. And then subtract 9 from both sides. That gives us 3x equals negative 12. And then finally, remember 3 times x, the opposite of multiplying is dividing. So divide both sides by 3. And you get x equals negative 4. All right, problem C. So again, draw your line. So on the left side, we have negative 2 times negative 2x squared plus x minus 5 equals 8x over 4y squared times 1 over y to the negative 2. So what we want to do here is, first of all, see which technique do we have to use. Since we only have one term outside, that means we can just use the distributive property to make this a lot quicker. So use the distributive property on the left side. Negative 2 times negative 2x squared gives me positive 4x squared. And then negative 2 times positive x gives me negative 2x. Negative 2 times negative 5 gives me positive 10. Equals, so remember to make sure that you guys are using PEMDAS when simplifying. So here I want to simplify what's inside the parentheses first. So if you notice, I have 8x over 4y. I can divide 8 by 4, and that's just 2. So 2x on top over y squared times. And then here, remember, when you have a negative exponent, you just take the inverse. So you just flip this fraction over. So that's y squared over 1. So I continue. If you notice again, the left side is going to stay exactly the same. That's 4x squared minus 2x plus 10. And then the right side, you want to make sure that you distribute this 2 to everything that's inside the parentheses. So that'd be 2 to the second power times x to the second power over y to the second power times y squared over 1. Now, if you notice here, whenever you guys have the same factor both in the numerator and denominator, they divide out. So y squared over y squared, that just becomes positive 1. And then on the right side, you have 2 to the second power, which is 4x squared. And then on the left side, we still have the same thing, 4x squared minus 2x plus 10. So here, again, we want to take our steps. We want to subtract 4x squared from both sides. And then when that happens, you have 4x squared minus 4x squared would be 0. So minus 2x plus 10 equals 4x squared minus 4x squared is again 0. Make sure you write it that time. So let me continue over here. And then subtract 10 from both sides. And then you guys have negative 2x equals negative 10. Divide both sides by negative 2. We get negative divided by negative is a positive 5. And then for problem D, what you guys should be trying there would be, so essentially, if you notice, we have 3/10 plus 2x over 5 equals 1/2. So what we want to try here is we want to get rid of the denominators, all right? And usually what I want you guys to try first is always make sure that you do the biggest, you multiply everything by the biggest denominator. So in this case, the biggest denominator is 10. So I'm going to multiply everything by 10. All right. So everything by 10. So everything by 10. So this goes away with that. And then make sure you multiply it times the second one. So 3 times 10 is 30 divided by 10 gives me 3. 10 times 2 is 20 divided by 5 gives me 4. So that's just 4x. And then half of 10 is just 5. So this becomes an easier equation for me to solve. So I'm going to subtract 3 from both sides again. And that leaves you with 4x equals 2. Divide both sides by 4. And that leaves you with x. Now remember, you want to reduce this to its lowest terms. And to do that, you just have to divide top and bottom by 2. And that gives you 1/2. That's the equivalent equation.